Hello everyone, Anthony here once again with I think should be episode 9 or is it already 10? Not quite sure, let me check. Episode 9. So for the people that don't know, for each episode I make a git tag on GitHub, so you can check out that code for that particular episode. So welcome, episode 9. Of creating a modular blockchain, modular production blockchain from scratch. And without any further ado, let's get started. So, the previous episode, we finished up sorting our transactions from the mempool. So let's quickly open that up. So when we create a block, we need to find a way to get all the transactions that are in the mempool, and we need to have them in a deterministic order. And that's exactly what we did previous episode. Right now, we are going to create our protocol. Important because if you want to communicate with other nodes in the network, we are sending them a couple of bytes, and without giving them a hint, without having some kind of an agreement on what kind of bytes we're sending and how do need to interpret it, it's not going to work. So we need to engineer a protocol. So what we're going to do is we're going to create a new file. We call this RPC.go. It's going to be package network. And a matter of fact, why is it not responding? Open up transport, because we have our RPC structure right here, and we're going to move it. Okay, that can be closed. So we have an RPC struct, but we need some other things. So let's first create an RPC handler, which is an interface handle RPC errors. Okay. So we need an RPC handler, which you could also call it a decoder, which is responsible for, let me open up server so I can explain a little better. When we are listening, or basically waiting for this RPC channel to be filled, it's going to be a plain payload with bytes, and we don't know what it is. So we need to have some kind of an logic that can convert a plain byte payload into some kind of a message, so we know what kind of thing we need to do with it. And that's what the RPC handler is going to do. And we also need an RPC processor, which is also an interface. And that's going to be, let's call it process. So basically, let's do it like this. Let's make it a net adder and current transaction. Please, transaction. Yeah, and maybe an error. Cool. So the processor is basically gonna take the encoded stuff from the handler, and it's gonna process it. And the processor is gonna have multiple methods exposed. For example, right now, the only thing we need is process transaction, but there will also be something like process block, process get blocks, process get transactions, and basically the whole processing of our protocol, which we will create. And enable, what the hell is this doing? Okay, cool. So we also need kind of a message. There will be a struct, and we give it a header. That should be in byte. Wait, I have a better idea. Let's do message type, and then we give it data, which is a byte, and type message type byte const message type tx message type 0x. So basically, Golang has no enums, but we could make something, unfortunately, by the way, but we could make something that looks very similar. Is basically something like this. So you give it a type, And then you make some constants. And if you do, for example, message type block, the only thing you need to do is put it below this, and it will automatically increment. So something like an enum. Something like an enum. Not quite yet, but still, it's similar. Yeah, so we make a message, we give it a header, and it's very important because this data, we don't know what this data is, right? We don't know what it is. So, but thanks to this header, which will be the first byte of the message, we know what kind of thing this data will be. And in case of a message type TX, it will be a transaction, so we know we need to decode the transaction. Okay. So let's make all default things implementation. So like default RPC handler struct, and we will take a processor, RPC processor. And what I mean by putting the processor in it will be clear later on. So default RPC handler. The RPC processor, yeah, RPC handler, return and default RPC process handler. Damn, this is confusing sometimes. RPC handlers. Like this, PP. Okay. And let's implement this. P this handle RPC error. No. Okay. All right, so what do we need? We basically because default RPC handler is the default implementation, it's basically our implementation. There is no need for us to again abstract the way we encode the message or decode the message. Even this message struct is basically highly coupled to is tightly coupled to default RPC handler. If people want to create a new or an other protocol, they can just create a new handler and do it their way. So there is no need to abstract the way we decode it. So we could do decoder is a hop decoder, no decoder actually, new decoder, and we take in the RPC payload. Wait, that's... Oh wait, we can actually make it even better. Instead of giving it bytes, we could say an IOTA reader. That would be super clean. Not gonna lie. Yeah. So handle RPC. So we need to have the message, which is a message, and then we say we don't even need this. You could say if s can decode and MSG and return the header here. Then we have our message, so we could switch on MSG pen header and say case MSG. Switch T. Can we do this? No. No. Wait. I'm confused. So it can be case message type. Yeah, message type TX. Okay. So here we're gonna handle. So we're gonna decode the message. So we know what the header is. And if we know what the header is, so the message type, we can act accordingly. So we say the TX is going to be new corpun transaction. And then we say tx.decode core.new decoder. We give it message.data, and this is getting in my way. R is not nil. Return R, and then is where the magic happens. Then is where I mean by why do we need the processor, is by saying we're gonna return P. This would be H, and we're gonna say H.P.process transaction, RPC.from, and the transaction. Okay. We could also say something, because we don't have any implementations, for example, for message type block, that's for later on. We could say if we don't have anything matched on these cases, we could say we could return error f invalid message type, and even say MSG.header, or actually invalid message header. Okay. Yeah. For the processor, we don't need any implementation for the processor because our server is going to be one. And instead of saying handle transaction, wait, first we're gonna find a way to get our handler actually inside of this. So we're gonna say server options, RPC handler, which is an RPC handler. And why my caps lock is doing crazy stuff. And because now we are a little bit blocked because the RPC handler needs a processor and our server is a processor, so we need to find a way to put the server inside of it. So we could say if opt.rpc handler is basically nil, then we're going to say that the ops.rpc handler is the new default RPC handler with a server, but we don't have the server. Maybe we can do this. Return S. Is this working? Probably not. I cannot use... Oh yeah, because we changed this to a reader, we will be in problem. Local transport, what's going on? Payloads, it's a byte, need a reader. Bytes, new reader. Okay. Yeah, it does not use, okay. So our server does not implement the processor interface, so we're gonna do this. So we say handle transaction is gonna be process transaction. And it takes an from, which is a net address, and we take the transaction. So that's cool. This is actually wrong. So we're first gonna hash, then we're gonna check the mempool. And then we're gonna verify, because we first wanna check if we already have it, otherwise we are verifying wasted bytes. And then we're gonna add it, and we need to, as far as I remember, set the first scene, which is needed for ordering, for sorting, time.now. Unix, no, I guess. Yeah. And then we add it to the mempool. Is this working? help. Somewhat. Yeah, yeah, we forgot. So basically, when we are in this RPC, we need to say aspend RPC handler. So instead of handling it ourselves, we're gonna give the responsibility to the RPC handler. Handle RPC, and it's an error, so we need to handle this. Logres.error. Like this. We cannot panic here because there will be a lot of issues. Well, there will be, most likely, there will be a lot of errors coming from handle RPC, because if somebody sends us wrong bytes or malformed payloads, and it's just daily stuff that will gonna happen, so we just log it and call it a day. Okay, so now we're gonna make run again. Make run. A panic. Segmentation. What is going on? I don't know. 85. What the hell? Network server. Yeah. I don't really like the way we gonna handle this. What I'm gonna do is I'm gonna do something like aspend server ops is ops. Okay, cool. Yeah. Or we make ops. We could make this a pointer, to be honest. If we make ops a pointer, we don't have an issue. But to be honest, it's not that bad, right? I mean, it's pretty nasty how it's looking, but we can fix it later on. Sorry for the noise on the background. I'm just trying to find a comfortable position. And unfortunately, my coffee is gone. So I'm a bit sad. Okay, so now we have a problem. Let's do it again. And unexpected AOF. So that's because, let's first make this error clear. Where is this thing? Handle RPC. So if we decode this message and there is an error, we're gonna make it more verbose and say error F. Failed to decode message from this peer. And the error is rpc.from and R. Failed to decode remote, yeah. So why it's remote is because, as you remember, let's go to help main. You could see we call this remote the remote, which is basically its NAT address. In TCP, you will see something like this, right? Okay, but for now, locally, you can call it whatever you want. Okay. What the hell is this? Yeah, it's probably... That's a byte. So is it X? I have no clue. I think it's X, whatever you want to name it. Yeah, so we're getting malformed message, and that's normally because if you check main, you see we are sending hello world, and hello world is basically not a valid protocol. So we're gonna fix this. Where is our message? We're gonna say new message T, which is a message type, data, which will be bytes, I guess, and then return a message, return message T, header T, come on, data. Okay, and now we need a way to encode this message, and because it's our message, it's our own implementation, our own protocol, we can actually do something very simple and say bytes, which is a byte slice, and we're gonna say buffer. Maybe I'm gonna find another way to stream this a little bit better. I mean, to stream the bytes over the connection and so a little bit better, but for now this would work. Bytes.buffer. I always say just get something working and improve it on. I'm a lot of progress focused, but you need to find a middle way, right? You cannot make things like spaghetti just to have something working, because it will shoot you in the foot later on. You need to find some equilibrium, right? So the buffer, then we're gonna say, because we use gob for everything right now, is basically gob.new encoder buff.encode this message, and then we're gonna return buff.bytes. Okay. Wait, so let's make a function send transaction, and what we need is a TR, is a network pin transport. Okay. Give it an error. Why not? This is a placeholder function. This is just for demonstration purposes, right? It's for making things work and see what we need to do. This will be no function and will be live or in production code whatsoever. Send transaction. So we're gonna say tx is new. It's core into new transaction. Data is gonna be a slice of bytes. String convert format int, and the way I'm gonna do this is the same thing as previous episode, where we want to have some random bytes so we don't have the same hash. Format int, it's an int64 rand.int 1000. Oh, good lord. 1000, and make this 10. What the hell? What the hell is going on? Format int, yeah, int64, okay, rand, yeah. So what the hell is he doing? N. Right, we did it. TX, and then we'd also need a priv key, going to be crypto.generate brief key, and then we say tx.sign. This is all, like I said, this is just for making it work right now. It's nothing too serious. So tx.sign. Then we're going to make a buffer, bytes, buffer. We're going to say tx.encode, yeah, core.new, the buffer, and say if the error, let's just check one error, right? I mean, we cannot skip them all. We need to be good father. Return the error. Okay, we have the buffer. Then we're gonna say message equals network new message. We say network message type tx, yeah, and we give it the buff.bytes from the transaction. Okay, and then I'm gonna say, wait, this is tr local, what the hell? Okay. It should be an address, right? Network, net adder, yeah. So we're gonna say tr send a message to 2, which is already an address, is good. And we're gonna say it's gonna be message.bytes and call it, this is gonna return an error, I guess. Yeah. Return. All right. So now send transaction tr remote. So our tr remote is going to send a message to tr local address, and we're gonna maybe check the error what's coming from this. Error is not nil. We're gonna say logarithm error. What the hell is going on? Error. Okay. Is this working? Make run. All right. Look at this. From the first time. What transaction already in mempool? Ha! What the hell's going on? Yeah, so transaction already in mempool. That's basically probably this RAN thing that's getting the same the same number. But first of all, let me do server. No, let's go tx pool. No, wait, I'm confused. I'm choking. Everybody's joking. Yeah, so adding a new tx to the mempool, and I'm wanna mempool length or len or length, whatever, length is gonna be p. Is this p? tx.p. Wait, where are we? Server. What the hell? Server.mempool len. And I just want to make sure. All right. Isn't it beautiful? Isn't this beautiful, guys? I'm starting to cry. Okay. So let's recap. Yeah, RPC. So what did we do? We created a message which consists of a header and its respective bytes. And we have an RPC handler, which basically is responsible for getting the payload, which is coming from the transport layer, and decode that stuff into a message. So then we can use the header of the message to see what kind of data this node is sending us and act upon that header. And for now, we only are implementing the message type TX, which means that we are getting a transaction either from a node that broadcasts its transaction to us or from our API, which basically, but yeah, for our API, we don't gonna use our RPC protocol, but it's gonna be the same processor. It's gonna be the same server. It's gonna be the same process transaction function, to be honest. Or maybe not, I don't know. Maybe we should, it's gonna be the same logic, but it's not gonna have the from, to be honest. Anyway, we will see later on, no big of a deal. So this is basically a very good start to, and I'm gonna check how much time we still have. We have 30 minutes, so we have something. So I wanna keep the videos around 40-45 minutes. We should test this also, but testing this is gonna take a long time. Well, not a long time, but testing this decently is gonna take quite a while. So I do it in a separate episode, or I do it off episode, off recording, off stream, whatever you want to name it. But it's very important we do. And actually, I'm a little bit concerned that how this is going to be testable. Something to think about, to be honest. So let's first do make test to see if everything works. Yeah. We broke something. Local transport test. Okay. Let's delete this. Yeah. Okay. What's going on? Yeah, so we consume and we say RPC payload is MSG, but MSG is a byte and this is a reader. How can we solve this? We could do something like we make a slice of bytes, which is basically the length of len MSG. Okay, and then we're gonna say rpc.payload.read this buffer. We're gonna assert. What does it return? This thing. I think read returns an error and the length. Yeah. So let's stop, please. We're gonna say n r assert equal t n len msg, and then we assert nil t r actually, and then we want to compare instead of comparing this MSG payload, we're gonna compare the buff with the message. Okay. I hope this works. This was the top of my head. Not gonna lie. All right, man. I'm insane. I'm insane. Not gonna lie. All right. I have to double check because consume. Yeah. All right. So our tests are working. Everything is working. We can. Let's open up main. To be honest. Be gone. So we made this nasty function enabled to send transactions from one so to say client to our yeah, whatever. We just mimic something. What we're gonna do next episode is basically make next episode or the episode after is we're gonna make some kind of a package or some tools to create a couple of clients, to simulate a couple of clients that have their own private key and public key, and they're gonna create some random transactions, and they're gonna push post those transactions to different nodes or to one node, whatever. So we can use that and able to simulate our system. And wait, another thing we need to do is server. Did we broadcast this already? Process transaction. So we're missing something. So we should also, we're gonna make it to do for this. Yeah, to do NTM what the hell, you know, plan to stop actually. Broadcast this TX to peers. Okay. So if we get a transaction, we gonna do our thing with it. We're gonna verify it. We're gonna put it into our mempool, and we also need to broadcast this to our known peers, so we can populate the network and make this super decentralized. Alright, I think this is it for this episode. I'm pretty happy with the progress so far, and we are again one step closer to the next milestone, which is basically having something that works. We just need to do a couple tiny bits here and there to make this something decent, to have a good base. So as usual, thanks for watching, and if you like what you see, please give this video a thumbs up and subscribe to the channel. It really helps me and I really appreciate it. Thanks for watching, and see you in the next one. Bye bye.